All right, everybody, good morning. I think I am ready to get started here. I don't have any housekeeping or anything. We've got class this morning and work time in the afternoon. So I guess the one thing is be on the lookout for our attendance message in the afternoon. Um, all right, well, let's jump right into it. So today we're going to be talking about databases and ORMs. And I think the first thing that I would like to say before we get started is um, thinking back to yesterday when I was kicking off the project and I said, "Oh, I got some feedback from the survey saying like, well, how does this directly relate to the project?" And just want to point out like these first couple of classes, we're gonna show you some code, but the idea here is not necessarily that we are showing you the code and you take it and do it in your project. A lot of this stuff is covering some key concepts that you might have been introduced to in the intermission work, and we're really just making sure we go over them again together in person and do some extra activities because these concepts are really, really important. Namely, they are sort of the foundation for what we're doing. So yesterday when we talked about how the web works, that was the foundation of where is our Rails app in the context of the entire internet. Today's class, we're going to be focusing on the database and how does the database work in terms of the Rails app. So we are taking like kind of a different approach. We're zooming in a little bit more, and we're really just talking about today the database, the ORM for the database, and that's pretty much it. So we're kind of like staying away from Rails a little bit today, but we are going to get into Active Record. So just right off the bat, like important to make distinctions between all of these things: databases, ORMs, the actual Rails app, all that. So our learning goals for today, we're going to describe what a database is and how it relates to web applications. We're going to talk about SQL or SQL and describe what that is. We're going to do some key database vocabulary. We're going to define table, column, row, primary key, and schema. So that's going to be kind of like the first part of class where we're going to like talk about some things. And then we're going to do a post-to-co activity where we're going to use this post-to-co tool to explore and visualize the database a little bit more. Then we're going to talk about ORMs and how that relates to the database. And then finally, we're going to use our ORM active record to CRUD resources. And we're going to do that in the Rails console. So that's a new tool that we're going to introduce today, or at least it's going to be new for us together. Yeah, so let's jump right into discussion. So I've got two questions for you all. I'm going to put you into breakout rooms, and I think I'm going to give you, I'll put a timer on for 7 minutes in these breakout rooms, and these are your two discussion questions. I did link the slides in the calendar event if you want to open up the slides and so you can keep track of these discussion questions and just kind of like keep track of what I'm doing. I know students find that helpful. The one thing that I ask you to do is don't look ahead to get the answers to these questions. Really like try to answer these questions before you look ahead. So again, those are linked in the calendar or the slides are linked in the calendar, and I'll just drop these into your chat right now. Cool. So I'm going to make these breakout rooms. Does anyone have any questions before I let you go? All right. I'm going to give you all 7 minutes. All right, welcome back, everybody. Am I screen? Yeah, I am screen sharing. I think I need to do my whole desktop actually. There we go. Let's hear from some random volunteers. Ben, what did you all talk about for what is a database?
Kyle actually, I gave a challenge to Kyle to sum it up in 5 words, and I already forgot what he said, but it was something like a structured collection of data or something, and it's basically laid out in a way that you don't you can have this big collection of data, and I mean that's kind of in the overarching sense that's what it is, but you can have different relationships to different pieces of data.
Yeah. Awesome. So like I would say that this having of relationships is kind of part of what you mean by structure. Like
Right.
this is one of our structures is that we can have relationships between different things.
Yeah.
I'd love to hear from Kyle. Do you have anything to add to that?
No, I guess I was just thinking about like relative to CSVs, where CSVs, it seems like to sort of go through them, you have to sort of like iterate through line by line and see if it's the thing that you want. But with databases, there are ways to like index those things so that you can find them faster and easier.
Yeah, so I might say that to contrast a database with CSVs, I might say databases are much more efficient. Yeah. So that could involve like finding a record in a CSV file. Yeah, you probably have to like just iterate through all of this. But databases have something called indexing that we won't get into too much right now, but it makes finding things a lot easier. So databases are better at that. Yeah. What other things might a database be better at than a CSV file? Alexa?
So I don't know if this is correct, but the way I thought
That's
about
okay.
it, with CSV files, it's kind of more of a snapshot of the data. It's not live. Like for example, when I was planning my wedding, I had a guest list with addresses and I had so many versions of that file. Whereas the way I think about a database, it's the one source of truth and you're more working with like one object, not a row, kind of.
Yeah. So I might say I don't think that falls under databases are more efficient. That's probably a separate bullet point here. Well, how do I want to summarize that? One thing I might say is like CSVs you can directly edit. So you can like save, you can create different versions. You could just go in there and like you could just change the text of it. So in this way, CSVs, this might be like a sub bullet point here of CSVs are overall less sophisticated. In terms of the snapshot, I would say both of them are kind of like snapshots, but the database, unlike a CSV file, doesn't necessarily store like, you can't store previous versions of it. Like we wouldn't want to store, wait, that's not true. We could easily store them. Alexa, do you think that this sums up what you were saying?
I think so. I think kind of just, yeah, because if you can't edit the database, it'll always be your source of truth. Is that correct?
If you can't edit the database, it will always be used. So I think one thing I want to point out here is that the database will the database will change. We're still going to edit it. It's just that we're not going to like directly edit it. We're not going to like go into the database and change things. We're going to interact with the database through a more sophisticated means. Let me pose that question to the group. How do we interact with the database? Genevieve?
You interact with it through SQL.
Exactly. So right here, we can see the difference between less sophisticated CSVs where you can just like, they're pretty much text files. So let me put that here. So like CSVs are essentially text. You can directly edit them. You can save, create different versions. With the database, we have to go through SQL. And that just kind of points to there is this much more sophisticated way. There are a lot more rules. Maybe I'll put that here. Lots of rules for interacting with the database. And those rules are essentially what SQL gives us. We can only interact with it the way that SQL gives us. And that's not entirely true, but in terms of what we're doing in our Rails apps, we're only going to use SQL.
And to just add another point like that, one of the upsides, obviously using SQL or using the database is you get to track the changes, right? A CSV file, anyone can go in and modify, and you won't necessarily know who made that change or when that change was updated if multiple changes have been made. Whereas in a database, you'll be able to track like this was updated on, when, and by whom.
Gotcha. So I would say we don't necessarily, the by whom part, we don't really have a sense of that. So for instance, our Rails app is going to execute the SQL. It's going to trigger this SQL to be run. So from the database's perspective, it's not like a person, it's not like a developer, it's just the application that it's connected to is changing it. So I wouldn't say we necessarily get like that kind of version control with a database. Now, something that you can do is you can export data from a database to a CSV file. So what that means is you could take your big dump of data from your database and export it to a CSV file so that you could then transfer it somewhere else. Or this could be your snapshot right here. This could be your snapshot of what was the database at this point. Well, we can represent the database in a CSV file. And that really points to that the structure of a CSV file and the structure of a database are very, very similar. So let me write that down as well. Structured very similarly. I want to hear some more about this. What do I mean by these are structured similarly? What are some things that they have in common in terms of structure? Jenny?
They both have rows and columns.
Yep. Perfect. Does anyone know what CSV stands for?
Comma separated values.
Yep, there you go. So in CSV, the way that we denote separate columns is through those commas. So each comma is starting a new column, and then each new line in it is a row. Jacob, do you have something you want to add?
No, I was just gonna say comma separated value.
Perfect. Cool. I want to hear a little bit more about what is a. Actually, I'll just open it up. Does anyone have anything they want to add on to either of these questions? Andrew?
Yeah, in my opinion, databases seem much more organized and easier to read than CSVs.
Mm-hmm. Mm-hmm. Yeah, so I'd almost say that falls under like CSVs are less sophisticated. I'll make a separate bullet point. So databases are more efficient. Databases are more organized. Alexa?
Is a database synonymous with a server when we look at our, okay.
Yeah. So that's I am going to draw you all or I'm going to show you all a diagram that will kind of like fit that into what we talked about yesterday. But for now, we're kind of like getting away from like client server, HTTP request response. Like the database, this is like a completely separate topic, and I'll do my best to tie them in together at the end. So let's go ahead and keep going with these slides. I think this is a good discussion here. Okay, so what do I have here for what is a database? So I have an organized collection of data that's very similar to what you all were saying. A key point here is that data is really what powers our web applications. If we didn't have this notion of data, of storing data, manipulating data, all of that, web applications would kind of be useless, right? What would Twitter be if we couldn't store tweets? What would Facebook be if we couldn't store posts? What would Wikipedia be if they couldn't store their articles? What would any of these apps be if we couldn't edit our personal information? If we couldn't send some data to say like, hey, this is my name and this is my password and this is the things that I'm interested in and these are the subreddits I'm subscribed to, or these are the whatever. So if we can't store data and we can't have a permanent way to store data, web applications are kind of pointless. So specifically, we're talking about persistent data. So contrast that with what you did in Mod 1, where you were writing you weren't writing web applications, you were writing Ruby applications. And when you ran that program, as soon as you stopped the program, it kind of like went poof. Like any data, if you're playing Battleship, for instance, you play the whole game of Battleship. If you just like end your program, your data, your game in progress, like just goes poof. So towards the end of Mod 1, we started to introduce you all to this idea of CSV files. Okay, here's what permanent storage might look like, and you just kind of connect it to your Ruby application, and you did that through what? What was the thing in your final or your group project that kind of like connected you to the CSV files? Can I get a guess? How do we interact with that CSV file from Ruby? Ben?
I would either say using that file IO or using that like CSV gem.
Yeah, exactly. So there are some like libraries that you have to use that do a lot of this for you. Same exact thing with the database. We're going to need to take advantage of some additional tools to connect that to our code. And we'll get there. So when we use a web application, when we use Twitter or Facebook or whatever it is, we are going to affect what is in the database. And this is where CRUD comes into play. So all of a user's interactions should do one of these CRUD things. So CRUD stands for, and if you don't have this written down, go ahead and write it down right now. CRUD, create, read, update, and destroy. Those are the 4 things that we can do with data in our database. We can create new data, we can read the data out of the database, we can update existing data, or we can destroy existing data. So if I am making a post on Facebook, I am creating some data. If I'm just viewing a post on Facebook, then I'm reading some data. If I go change my Twitter profile information, I'm updating data. If I go delete a tweet, then I'm destroying data.
Hey, Brian, sorry to interrupt, but has your slide changed? I feel like it might be frozen on my end, but I don't know.
Has my slide changed?
All I see is what is a database, structured collection of data, and like very faint can have relationships. I don't know if that's what you're seeing also.
That is not what I'm seeing. Is anybody seeing the same thing?
Yeah, I see that.
That's what I see too.
Yeah,
I thought
it's the
that was
same
on
thing.
purpose.
Yeah, that's what I see.
Okay,
Oh,
what
it's
do y'all
better.
see now?
That works.
Looks
It's just
fine
like
right now.
frozen. Did you all see these slides?
I did not.
Okay, but you can see them now. Okay. Thank you for letting me know, Jameson. I have no idea why that happened, but there it is. So this is kind of what I was talking about in written form. So I'll give you all a second to take notes if you need to. And I think this is probably a good place for a POM as well. So let's come back at 9:35. You can take an extra minute or two if you want to take notes. And yeah, we'll get back up in 7 minutes. All right, let's go ahead and pick back up. If I could just ask everybody to turn your videos on if you're back, and I will continue. So one thing that I didn't quite say that I do want to say about these CSV files is I really want you to think of them as a database is like a CSV file on steroids, or it's like a super CSV file. We didn't show you CSV files in Mod 1 for no reason. They are very, very similar to databases. It's just that databases do a lot more on top. So if this is like kind of a lot of information right now, the whole point of this is CSVs, databases, very, very similar. Database just has some like extra cool features on it. Ben, I see you have your hand up. Is that from before?
That's old, sorry.
No worries. No need to be sorry. Cool. So let's keep talking about databases a little bit, and then I'm gonna send you off on an activity. So databases need a database management system. And this is the thing that governs our interactions with the database. So in Mod 2, we're going to use PostgreSQL. So just in case you're wondering, like, okay, we're talking about databases, is that PostgreSQL? Technically, PostgreSQL is not the database. PostgreSQL is the database management system, and the actual data is the database, which can be kind of confusing. Some other examples of database management system, SQLite, I believe, was in one of the Jumpstart Lab tutorial that you all look through. So this is another example of a DBMS. Typically, we don't really use this term DBMS. We typically just say the database. So I will say Postgres is the database. So the point of pointing this out here is you'll see this term DBMS or database management system, and it's really like not commonly used, but if you do see it, this is essentially our database, which is Postgres in our case. Okay, so let's talk about relational databases. So relational databases are what we are talking about in Mod 2. I don't think I have a bullet here. Yeah, so there are other types of databases like NoSQL databases, but we are not going to cover them. So all of the databases we are going to talk about are specifically relational databases. Now, if you get into Mod 3 and Mod 4, you have a little bit more choice in your projects. This is something that you could experiment with. What are some other types of relational databases? This is very similar to how we introduce you all to object-oriented programming, but we don't actually show you like what the opposite would be. Like what is something that's not object-oriented programming, like functional programming. So I want you all to know that there are like other ways to do this. The relational database isn't the only way, but it's what we are going to cover. Relational databases have a strategy for organizing their data, and this is called the database schema. So let's talk about this database schema more specifically. Yeah, Kyle.
Before you move on, is there like an important distinction between GraphQL and other SQL databases?
GraphQL is I haven't worked directly with GraphQL. Jameson, have you used GraphQL before?
I have not.
Gotcha. Yeah, so my understanding of GraphQL is that it is essentially a wrapper on top of your database. So it's not like in substituting for your database, it's making, it's like a separate way to access the database, if that makes sense. And that's me talking about something that I've never used before. So take that with a grain of salt. Anything else before I move on? I do realize I'm going kind of fast here. The next activity, I want you all to explore these ideas a little bit more. So when I say schema, remember this is the strategy for organizing the data. Well, what goes into that strategy of organizing data? The first thing that we're going to have is tables. We're going to have different tables, and these tables are collections of related data. Related as in they are the same thing. This is also referred to as a resource oftentimes. So just a bit of vocab. There's a lot of vocab in Matsu, and a lot of things like mean the same thing. So table, resource, those are synonyms. So an example of this is your task from Task Manager. Your task table stores the collection of related data that it's storing is just tasks. They're all related because they're all tasks. Another way that you can think of this is that this is the nouns of our application. So if I'm thinking through something like Twitter, well, what nouns do we have in Twitter? Well, we've got users, we've got tweets, we have hashtags, et cetera, et cetera. So each one of those things would be its own table of data or its own resource in an application. So when you're thinking through like what table should I have, you can think of what nouns do I have for this application. So these tables are going to consist of columns and rows. So a row is an entry into the table. So if I have one row in my task table, I have one task. If I have two rows, then I have two tasks, et cetera, et cetera. This is also called a record. So if I have two rows in my task table, I have two task records. So again, some vocab that can get confusing. These are really synonyms. A row and a record are the same thing. And then finally, we're going to have columns in our tables. So the columns are the attributes in that table or the attributes of that resource. So for example, a task would have a title and description. So we would have one column for title and one column for description. And that's what we have in Task Manager. Okay. What questions do y'all have? All right, let's keep going. Let's talk about primary keys. So primary keys, typically every table is going to have an ID column. And I say typically because you don't have to have an ID column, but when we are working in Rails, every one of our tables is going to have an ID column. So unless you like go out of your way to remove the ID column, so I don't even know how you would do that, every table is going to have this ID column. This is the unique identifier for each row. So if I have two task records, each one will have its own unique identifier so that we can uniquely identify them. We don't want to use an attribute to identify a record like a name, because it could be possible that two names a task could have the same name or something like that. It's also less efficient to look up things by an attribute. So this ID is how we will always identify a record. And so we refer to this ID as the primary key. So in database, when we're talking databases, key is key, identifier, ID. These are all like related concepts. We are going to get into foreign keys, but we're going to save that for the one-to-many class. So today, we'll just talk about primary keys. And then SQL. So SQL stands for Structured Query Language. I think I've heard people have opinions on how you should pronounce it on SQL or SQL. I don't have a strong feeling about it. So this is used to query relational databases. So Structured Query Language, we use it to query relational databases. What does that mean? What does query actually mean? Well, this is our CRUD actions. Again, this is coming back to CRUD. Any query that you can make is CRUD, creating something new in the database, reading something, updating it, destroying it. This is one example of how you could query a database. Another thing that you could do is you could do data analysis. So for example, we have this big collection of data. Imagine we're like making like Amazon or some sort of like shopping app. Maybe we want to know something like which merchants have generated the most revenue, who are top performing merchants. Maybe we want to give them a bonus for being such good merchants on our platform. If we're doing the pets and shelters example, maybe we want to know which shelters have the fewest pets so that we can offer support to them or whatever it is. So this is data analysis. This is another category of what you might use SQL for. And then the final thing is you can use this to alter the database schema. So if the schema is the tables and the columns and how the data is structured, we could use SQL to change that. So for example, we could create a new table with SQL. We could remove a column with SQL. We could add a column. We could change a column name. We could change the data type of a column. We could change the data type from a string to an integer, something like that. We won't do that too often in practice, but I do want you to know that this is something you could do with SQL. All right, so we're gonna do our post-to-co activity next. Let me introduce this. So in the lesson plan, this is linked in the calendar. In the lesson plan, it's going to be right here called post-to-co activity. And so I want you to work through these as a group, these tasks as a group, and as you go, answer these questions as a group as well. And then if you have time, there are some extensions down here that you could work through as well. And I think that is about it. So let me show you what this should look like. I want everybody to follow along with me right now. So like getting post-to-co up and running, not always the most straightforward thing. So go ahead and just follow along with me. And if you run into any steps, you can hang behind before we do the breakout rooms, and I'll help people out. So what I'm going to do is I'm going to open up post-to-co, and I use Spotlight Search for doing that. And so this is going to pull up, let me pull it over here. This is going to pull up this. Can everybody see my elephant here? Cool. So this is going to pull up this elephant here, and I should be able to click. What yours might look like at first, if you haven't done this yet, is it might fill in host with localhost, port with 5432, and user with whatever your username is. So mine is Brian in this case. And then I'm going to hit connect, and this should open this up for me. Now, if this, can I get a yes if you all were able to, if you are able to get this far? Cool. So it looks like most people, but not everybody quite got that far. Okay, so if you didn't get this far, hang back and we'll address your issues as they come up. Hang back before we do breakout rooms. So the next thing that I'm going to do here is I'm going to click on this local host up here. So this is kind of like a folder structure. This is connected to a database called Brian, but I don't actually want to connect to that. I want to go back to this elephant right here, and this is going to show me all of my databases. Now, I probably have a lot more than you do. So what you want to do is you want to go find task manager development here. It should be in alphabetical order. And here it is for me, and double click. And I should see my task table from my database. And then if I double click in here, I should see some tasks. Okay, so I'm going to create some breakout rooms right now. And if you, actually, let's do this. If anybody, can I get a no reaction if anybody is, for whoever is not able to get this far, connecting to your task manager development. And while you're putting that up, Joseph, do you have a question?
Yeah, I was wondering, do we want to be encrypted? I was trying to log in with my SSH key and was struggling to make that a possibility, and I was wondering if that's necessary.
It's not necessary. So none of the data that we're working with here is highly secure. So
Sure.
on a real world scenario, we're not going to do any of this because we wouldn't want to like directly mess with our data. But right now we're just exploring and experimenting, so it's not an issue.
cycle.
Oh, those no reactions don't stay, do they? Dang. Well, can we do it one more time? Can I get a no from the people who had some issues? Cool, so I see Doug and Diane. Perfect, okay, so I will help you two before we go into breakout rooms. Cool, and I'm just gonna put you all in the same groups you were in before. And if you have any, I'm gonna put the timer on for 20 minutes here. If you have any questions, use the ask for help button and that will send a message to us. And let's get Diana, can you share your screen and can you show me what you're seeing on your end?
I was having issues too,
Absolutely.
Brian.
Perfect. Well, not perfect, but we will get those figured out.
Okay, and then let me just get the little error message that I'm getting. If I can move it, there it is.
Okay, so could not connect to server, connection refused. Is the server running on host, local host, and accepting connections? So go in your top, in the top of your screen, the elephant in the top right menu bar. Yeah, and then click, see how it says at the bottom, Postgres 13, there's an X, and then you should be able to click that start. Can you click that? Okay, so click open Postgres. It looks like we're having an issue here. Let's click check automatically. There could be, yeah. So try click start again, and there we go. So the data directory contains an old postmaster.pid file, data directory, blah, 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 blah. Okay, can you click OK? So this happens sometimes. We'll get, Postgres uses this, this file called postmaster.pid to kind of like keep track of the current like running Postgres session. And if you don't shut down your computer properly, or maybe like it runs out of power, or for whatever reason, it doesn't shut down correctly, we need to go find this file and delete it. So if you click on server settings, that should help us figure out where this file would be. So I see data directory, I see users, Diana, library, application support, Postgres. Cool, let's open up a terminal and let's see if we can follow that path.
All right. Then, oh no, it went away. Okay. What was it? Bam.
Yeah, so we're already in your user directory, so we should be able to go to that application support.
Oh.
Can you do LS?
Yeah. That'll be better.
Oh, can you click on server settings again? I forget where it is.
Oh, library.
Library, that's it. There we go.
Okay.
And I think we're looking for Postgres. Yeah. Yeah, I see it there. Cool. And then do LS in here. Yeah, we just have that version 13. So let's go in there. And let's do LS. And do we find our postmaster.pid? I see it there in the bottom right. So yeah, let's do rm postmaster.pid. And then let's go back to our Post2Co app and try to click start. Yeah, so now it just says not running. Boom, there we go. And Yeah, now you should be able to, it looks like your version, you might actually be on a newer version than I am. Is that true? Oh, never mind. Sorry, I'm thinking of Postico. Okay, so now that Postgres is running, you can exit out of Postgres. Click the top left arrow on it.
Okay.
Or sorry, the exit. Yeah. And now let's try to connect to it through Postico. There we go.
There it is. And what's
Awesome.
Okay, I think I can get my my breakout to get me through the rest. Maybe.
Perfect.
Thank you.
You're welcome. Did that fix anyone else's issue?
Brian, I just didn't get sent to a breakout room. I just didn't want to interrupt, but
Oh, sorry,
I
Trevor.
just have a room.
Sorry. I will get you. There you go. And Doug, what are you seeing on your end?
I think I maybe figured it out. I hadn't actually put Postico in my applications, and so it was not showing up when I was spotlight searching. But now I don't know where to go from where I'm.
Can you screen share? You're on mute, Doug.
Okay, I am here, but I didn't know. Yeah, at first I wasn't finding anything except for a version to buy it in the App Store for $50. And then I found it in my downloads. So I got to here, but I don't know where to go from here.
Perfect. So in that, I'll just circle it for you. So up here, click on that local host.
Okay.
And then you should be able to find Task Manager Development. Yeah,
There we
you
go.
look good to go.
Perfect. So now I just got to figure out how to get to my breakout room.
That's another challenge.
There we go.
Okay, so now I have a question.
Yes.
I haven't used Postico in a while. Is there a way to run SQL directly in Postico, or should we be using PSQL?
Yes, there is. Let me.
Okay.
Here, SQL query.
Thank you. Okay, that was all I was looking for. I'll go let them know.
Perfect.
I don't know why should so like if I get out of here, I can do what you said. Task manager development.
Yeah.
Okay.
Select. Yeah. Oh, you need to put a semicolon after tasks.
Okay.
I just hopped into another breakout room, and I think they're going over the same thing. So I'm just figured we could do it together.
Cool.
All right, welcome back, everybody. I wanted to end these breakout rooms a little early so we could do a quick check-in to see where everybody's at. So can I get a yes reaction if you were able to work through everything up to the extensions? So you're able to do these tasks in Postico and you were able to answer these questions as a group. Cool, so not quite everybody is there, so I'm going to give us, oh man, I really wish, can we do, instead, can we do a raise hand reaction if you were able to get through all that? Yeah, I guess the hands are permanent and the checks are not permanent. Okay, I'll just keep that in mind for future use. Cool, so yeah, not quite everybody's there, so I will give you all a couple more minutes in your breakout rooms to work on this. I did want to show you all briefly because I saw some people were having trouble executing SQL queries. So for the extension, it says try to execute the following using SQL queries. The easy way to do that is in Postico. Come on. Cool, I'm already on Task Manager. So I have my task table here, and I can go up here to SQL query and double click on this, and this will give me a nice, easy way to write SQL queries. So this is the way I'd recommend that you write your raw SQL. I don't want to give away too much there. Yeah, so I'm going to, I can lower all hands. So I'm gonna lower everybody's hands. Does anyone have a like question about the activity before I let you all go back into breakout rooms? Ben?
I just kind of had a question about some of the syntax, like in the PG exercises. It was, you know, when they had the select blah blah blah, they didn't include the star. So is that like star if you don't put anything there? Is it like selecting all by default?
So star means every column. So
Right.
if I do select, if I do select, what am I doing? Tasks.star from
Oh, I see.
tasks. This means tasks is my table, and then dot star. The dot means what column are you selecting from the table, and so if I say task.star, that means every column from that table.
And if you just have the select from, like you don't put anything in between there. What's
So-
like the default quote unquote argument there, or like what is it?
So typically I will never write a SQL query this way.
Okay.
I always want to like say what I'm selecting from. I don't actually know what this would, did it do anything? Yeah, so I think it's just selecting nothing. That's
Okay,
my
I see.
guess. So yeah, I can also, a shorthand for this is select star from tasks. Cool. Yeah, any other questions about this activity? Joseph?
Yeah, I was wondering how necessary it is to write the commands in all caps, if that's a stylistic choice, or, you know, I notice it seems to be whether you want to do it or not.
Yeah, completely case insensitive. It's up to you. I think the style that I see pretty often is that commands will be capitalized, like select and from. You can see they're even highlighted, and then the table names and the column names are lowercase. Did I say highlighted? I meant uppercase, capitalized.
Capitalized. They do like turn blue, it seems.
Yeah. Yeah, so if we're looking at posted code, the blue words will be written, but yeah, you can write them capitalized, not capitalized.
Cool.
Cool. All right, so I'm going to send you all back in your breakout rooms. We'll do another 7 minutes, and then when we come back, we'll take a palm, and then we'll go over this together.
Testing database where you can just try new things and like see if your new feature works, whatever. And then if it does, you can probably like push it up to like the actual database.
Sorry, Jake, I got a little distracted there. I saw in the chat that we weren't recording, so I just clicked record. So
no, to say it's all good. I was like kind of rambling.
Well, the first thing I want to say is like, yes, you don't know the answer to this question, and that's totally fine. Like, I wouldn't be answering it if I expected you all to know it. So like, not knowing that's where I want you to be. The first thing that I think I heard you say is like, you want to have your separate test database because you want to like test things separately from your like normal database. Is that kind of what you're saying?
Yeah, just like basically like a sandbox. That way, like if you are in the real world and you're like working for Airbnb, you like don't destroy all the bookings when like you're testing some shit.
Yeah, exactly. And so we're actually going to have 3 different databases. And we'll talk about this a little bit more when we get to the next project, but there is a third database that would be the production database. So that's kind of what you're talking about, Jake. Production, meaning like if you kind of like think about it as like a play, like this is the actual production. We're actually like putting on the show here. So production is like where the real world data is being stored. That's like the real app where people can access it from all over the world. That is what production is. So development and test, I want you to think of both of those as sandboxes. Development is a specific sandbox and test is a specific sandbox, and they are both with the they both have the purpose of like we're using them to build up our application, but that's not where the actual data is stored yet.
So following that analogy, then testing, the difference between the test database and the development database would be like test is like we're like literally throwing shit at the wall and seeing what actually works, and the development is like, hey, we have an idea of like these small pieces work, and development is like putting the bigger pieces of the puzzle together. Like
not exactly. Yeah. What's I want to hear from someone else. Like, how would you describe this like different development and test thing? I'm intentionally trying to be vague about it. Kyle, what do you think?
I think I had the understanding that the specific test database is like similar to a mini test. Every single time we run a test, we have a setup and then we have the execution, and then we have the breakdown, and that is why the test database was empty, because it gets broken down after each test gets run. And then the development is sort of, that sort of like continues to be added to, or we can continue to work with that like throughout our development.
Yeah, you're on the right track there. So our test database is specifically for when we run our tests. So just like in mini tests, how nothing really like persists, we want the same behavior in our test environment, and we're going to use RSpec, so it's not mini test. But yeah, that test database is the reason why we have a separate one is because we want to have like a separate, clean working copy every time we run our tests. And yes, that is why it's empty, because we tear it down after every run. If there was data in there to start, then that could throw off our tests. So really, I'm not gonna, this is like a good intro to like start talking about like development versus test. We are gonna have more testing classes, and we'll like get into that a little bit more. But the thing that I really want you to understand at this point is that there are two separate things. There is this test database where that has to deal with our running tests. And then there is this separate development database. And I want you all to, can I get a volunteer? How do you access your development environment? How do you get to your development database? What is something that if you think back to like your task manager and you filled out a form to create a new task and you hit submit, what did you have to do to like get access to viewing that app in, if you remember, you go to like localhost 3000. What do I have to do before I can do this? It says like, this site can't be reached. It refused to connect. Doug?
You have to go into your terminal and then run Rails S or Rails server.
Yeah,
to
exactly.
Kind of start the application.
Exactly. So we have the, so if I go over here and I go to, let's find, where do I want to go to? Do I have a...
Brian, you don't have your screen share.
Oh, I'm not sharing. Thank you. Let's go to, oh, I don't have one, do I? Oh, there it is. So if I go here into my setlist app that we don't have yet, we'll introduce this later, but this is just like another Rails app. If I have to run Rails S here to run my server. So I want these, and this isn't quite gonna work because, yeah, I don't know, but I will have to like look into that separately. I actually don't know what copy this is. But for now, I want you to have it in your head that the development environment, the development database, and the Rails server all work together, and the test database and your RSpec tests that we haven't written yet, but we will write them eventually, those all work together, and those are separate environments. Kaya?
Where does the Rails console come into play with those two other relationships?
That's the third thing. That's the third way to access your development database, and that's what we're going to do in the next activity. For now, I just want to start this as early as possible. Rails server, development, tests, test environment. How would you describe your task manager development database's schema? Can I get a volunteer for this question? Chris.
Yeah, not 100% sure, but I think it's sort of like a blueprint for like the table that you want to create. So for task manager, we want to create like a task table, and then it gives you like each column's attribute, like it'd be a string or an integer or something, and then it creates it for you.
Mm-hmm. So let's check out our database here.
Brian, we're not seeing that. We only see, looks like your Zish file.
Looks like it might be frozen again, yeah.
Oh, man. Okay. I don't know why this is happening, but what about now?
Just a
Can you
black screen?
Just a black screen.
Just a black screen?
Well, it says that you started screen sharing.
What if I do this? Is it a black screen like my terminal or just like a fully black screen?
All I see is Brian's auntie he him who started screen sharing.
What the heck?
Yeah.
How about, let's do this. How about that?
Same thing.
Oh man. I do not know what's going on with that. Okay, let's try. Can you see that? Man. I don't know what I'm going to do about this. Let's see. What can I do? Try one other thing here. Still nothing. Does it still say I'm screen sharing?
Yep.
Maybe I need to update Zoom or something. But you could see it earlier. That's weird. Okay. Well, let's do this. Let's take another break here. I know we just had a break, but give me 5 and I'm gonna see if I can figure this out. So I'll plan to start back up in 5 minutes at 10:51.
Do you want us to hop off the Zoom and we can like hop back on in 5 minutes so we can restart it?
Let's if we need to do that, we can do that in 5 minutes. Yeah. Jameson, can you help me debug this a little bit?
Yeah, absolutely.
Can you see my calendar if I share
Yes.
that?
Yes.
Okay,
I
so
see your
that
calendar.
worked. And okay, so let's try that again over here. Can you
Okay,
see?
now I see your desktop.
Okay.
Now I see your slides.
Okay, so I guess we're back. Okay, well, I'm not gonna look a gift horse in the mouth, I guess.
Yeah, that's strange.
That was very strange. I'll update Zoom after this and just maybe there was something there, but yeah, it was weird. What I just did was I shared my other desktop, on my laptop and not my external monitor, because I don't know if that's the difference.
Oh, weird.
Not sure. Okay, well, we will, I'll start back up at 51.
As a side note, I found that if I share a screen versus a window, when I share windows, I have problems in Zoom versus if I share a whole screen. I don't know if that had anything to do with it.
Yeah, that might have been it, because I think I did exit out of my screen share of just my Chrome app so that I could show Postico too. And that's when I think I started having issues. But we also had that earlier when I was doing the slides and I wasn't doing the full desktop. I don't know. Okay, we'll move forward. 51. All right, everybody. Sorry for the technical issues, but I think we got it all figured out. Y'all can see my screen now? Okay, cool. So let's finish up with this last question here. And I forget who was answering this one. How would you describe the database's schema? Was that Chris?
Yeah, that was me.
Awesome. So I'm going to open this up. And Chris, can you describe us that you did this earlier, but what do I mean by the schema? What are we looking at?
Yeah, so basically like looking at the tables that you're going to be creating. So kind of like the layout or like some sort of like blueprint. Mm-hmm. And it's going to have each column with its like data type with it as well. So
perfect. So looking at this, which tables do we have?
Looks like you have just tasks table.
Yeah, and good job not like looking at these two tables. These ones are kind of like default in Rails for AR, internal metadata, and schema migrations. We don't need to concern ourselves. So really the table we have is tasks. And then how is this task table structured?
With an ID, title, and description.
So, and what data types are the title and description?
Text, basically, and then integer for ID.
So. Yeah, and you could also say strings for the title and description as well. You could click down here and see structure, and this would give you a lot more detail here. So like this ID column is a big int. So it's an integer, but it's specifically a big integer. And it has this sequence and its constraints are that it's a primary key. So you could click down here and get some more information. But for now, what I'm looking for is describing the tables, the columns, and the rows that we have. That is our schema. Cool. So I'm not going to buy Postgo, and I'm going to move on with my slides here. But does anybody have any questions from that activity before I move on? All right. Well, let's keep going then. So now that we've explored databases a little bit, we're going to layer on something else onto our database, and that is an ORM. So what is an ORM? An ORM stands for Object Relational Mapper. Its job is to transform the raw data in our database, into objects in an object-oriented programming language. So why would we use an ORM? Why don't we just work with the database directly? Why do we go through all of this trouble of transforming the data into objects? Well, working with objects is easier. This is probably the #1 reason why we would use an ORM. As we could see from some of the SQL syntax, it's not always very straightforward. SQL syntax can get like kind of messy, and SQL can get really long and complicated. You also can't easily break SQL into multiple lines. So what you learned in Mod 1 of like make things readable, don't put too much on one line, can't really do that in SQL. So we want to transform it into something that we just know how to work with easier, which is Ruby. This also gives us a lot of nice syntax. So SQL syntax gets really, without an ORM, we would have to write that raw SQL, and that can get really messy, as we've already seen. Another good reason to use an ORM is that it is database agnostic. So you can think of the ORM as an adapter to your database. If it transforms data into objects into an object-oriented language, we can work directly with the ORM in our object-oriented language, and we don't have to worry about what database is on the other side. So for example, if we're developing in Postgres and then we decide to switch databases, our ORM shouldn't have a problem because it knows how to adapt from one database to another. So it does a lot of that for us. And the last thing I have here is security. We're not going to dive too deep into security this mod, but the ORM, going through the ORM will prevent from some common attacks like SQL injection that if you are writing raw SQL, you might not protect from. So yeah, this is not something that you need to know deeply, but it is good to know, like the ORM gives us an added layer of security. I'll give you all a couple more seconds to take notes before I move on. So let's talk about active record now. What is active record? Active record is our Ruby ORM. So ORM in general transforms raw data into objects in an object-oriented language. And when we're working with Ruby programs, we use active record to transform that raw data specifically into Ruby objects. So these are Ruby objects, just like you worked with in Mod 1. They behave very, very similarly, but the ORM adds in some extra things on top of them. So in the same way that we worked in Mod 1, we worked with Ruby objects and data stored in CSV files. Our CSV files are getting more sophisticated. Now we're using databases. Our objects are getting more sophisticated. Now we're making active record objects. So in Rails, how do we do this? We create active record models. So these models inherit from active record base. And this is a code snippet of what this looks like. So what we actually have is we don't have a model inheriting directly from application or from active record base. We actually have an application record inheriting from active record base. And then we have a model, our task model, inheriting from that application record. So I would say that the task inherits from active record base through the application record. So it's more of a two-step inheritance. But the key thing here is that at the end of the inheritance chain, we are inheriting from this active record base here. That is what makes this a model. That is what makes this an active record model. Let's talk about the Rails console. So Rails gives us by default access to the Rails console. And you can access this by running Rails console or Rails C from the command line. A lot of things in Rails are abbreviated. So Rails server, you can abbreviate with Rails S. Rails console, you can abbreviate with Rails C. This is a REPL. A REPL stands for read, evaluate, print, loop. So this is very similar to Pry, where it gives you an interface where you can execute a line. It will print out the return value, and then it'll loop back to the beginning, and it will continue that read, evaluate, print loop over and over again. So this is, you can kind of think of this as like executing a Pry session. But the big difference between Pry and Rails console is that when you run Rails console, it loads up all of your Rails application. So technically, this is going to open an IRB session, which stands for Interactive Ruby. You might not have used IRB because pretty early on, we try to get you all working in Pry. So this is kind of what I started saying. This loads up your entire Rails application, including your models. So this is an easy way for you to get access to your models and to interact with them. So if you need to interact with just your models, you typically do it through the Rails console rather than running the Rails server. So this is what I just said, useful for interacting with your models. So our next activity here is going to be working through the Rails console activity. Just like before, I want everybody to be completing these tasks on your own computer, and I want you discussing as a group. And if you finish these, there's no check for understanding, there's no extension for this Rails console activity. So I want you all to go into these checks for understanding if you've finished early. Yeah, so I imagine you all might have some questions about what I just covered. I would ask you all to just try and work through these activities and answer your questions on your own. And when we come back together, we'll do more of a big group discussion. Yeah, and I think that's about it. Does anyone have any questions about what I'm asking you to do? I'll put 20 minutes on the clock for these breakout rooms. All right, if anything comes up, use that ask for help button. Otherwise, we'll be hopping around rooms and be there to help.
Brian, I don't know if I'm being thrown into a room or not.
I see that. I'm going to assign you both.
Samesies. Cool.
Yes, we don't want Ben to just be in a room by himself. We want Ben
Oh,
to
so
have some
sad.
partners. All right, welcome back, everybody. I wanted to bring everybody back early. I saw one group run into some issue, and I think probably most people are going to run into this issue. So I wanted to do it together. Andrew, would you mind screen sharing and showing us what we're running into?
Yeah, so I was creating a new task in the IRB, and I had basically, what was it, 4 tasks in here with ID 2, and then the laundry one wasn't here, 4, 5, 6. And when I created the new task, it had me just do the title and description didn't have me insert an ID or anything. And I figured it would take an ID of 7, but it took the ID of 3 and plugged itself in here in the middle. And then when I tried to create another one, it was basically saying duplicate key value violates unique constraint. And it was trying to give it an ID of 4. And we already have something with an ID of 4.
Mm-hmm. Yeah, can I get just like by head nod? Did anybody else run into this issue? Yeah, a couple people, yeah. So what's going on here is normally, could you click on that structure on the bottom, Andrew? Yeah, so we looked at this earlier, but we can see that the default, let me use my annotator so I can highlight here. So we can see under the ID, the default is it's sequenced and its constraints are that it's a primary key. So as we mentioned earlier about primary keys, they are unique. So you cannot duplicate primary keys. And there is a specific sequence for these IDs, which is just that they will count up. The first task will be ID 1. The second task will be ID 2. What happened here was when we manually used Post-to-Code to edit it, we did not, we messed up the sequence. We completely messed up the sequence, and our Rails did not see that sequence was changed. So it tried to go, we must have created 2 tasks earlier, and then when we try to create a third one, Rails doesn't know that we've already created a third one, and so it tries to do number 3. And I think that one actually worked. So then it does number 4, and we already have a task 4, so that won't work. So Andrew, something else that you asked me earlier was in that Rails console, would the solution, let's go back to our task table. Would the solution here be to add in an ID into that creation? So let's show what that would look like. If you go to your console, let's hit the up arrow to get that same command. And then let's add in an ID key here for 7. And let's hit enter. And then in our Post-to-Code, let's hit refresh. Okay, so we can see that that worked. You do not want to do this. So I want to show you this because it will work. And so it might seem like this is a good solution here, but you never ever want to manually assign an ID. We'll talk in the group project, we'll talk about a time when you might want to do that. But for now, you never want to manually assign an ID. You always want to let Rails just assign the next valid ID. So this process of what we did in the first Postico activity of like creating tasks manually, this is not something that we would ever want to do for this exact reason, because it will mess up our primary key sequence. So that Postico activity was really just like experimenting and seeing what you can do, but we don't actually want to do it for that reason. So the easiest fix that I can think of here is let's just delete these 4 tasks, and we'll kind of like have we'll do our sequence. So yeah, I think if you do like shift click and you shift click on 4 now, it should highlight all of them. And now double click, and we should see an option for delete those.
Nah.
You can't double click and get options on those. How
the default might be control click.
You can right click on it.
Cool.
There we go. Yeah, and then it's asks us if we want to save changes. So we'll save changes, boom. So now let's try to do our command without the ID to create a task. There we go. So let's hit enter there. And now we can hit refresh on Postico. There we see now it took ID 5. Let's do the same thing again. Let's create another task in our console and hit refresh in Postico. Boom. Okay, so now our sequence is back in line. So that's a big gotcha that you might run into. Yeah, is anybody running into anything else that you feel like we need to address as a class before we go back into breakout rooms? Yeah, Genevieve, what's up?
Well, I was just curious, and I don't know, maybe this will come later, but how would we auto increment if, for example, we did actually get this error? How would we be able to do it without having to go delete rows in the database to make it work?
There is a piece of code that you could run, which will reset your primary key sequence. And yeah, so you can do it in code, but this is just easier. So if you're curious, you can Google that on your own, but that will come up in the group project.
Okay, and you said it's to reset the primary.
Yeah, you can
key
Google
sequence.
like active record reset primary key sequence.
Okay, perfect. Thank you.
You're welcome. All right, y'all. I'm going to put you back in your breakout rooms. Hey, was that what Kyle was running into?
No, I think he was using his database somewhere else. He got that already in use when he tried to run RailsDB drop. And I think he was still working with like task manager. So he was trying to drop so he could start over.
Oh, and that was his question about how do I start over?
Yeah, I think maybe when he was working on this also, though, he was running into issues because there was like, it was telling him that he was accessing the database somewhere else, but we got it figured out.
Was it like a Rails server somewhere or something?
I don't know. I think he closed it out while we were back here in the main room, but when I went back in to double check, he said that it was working.
Gotcha. Okay, cool. Yeah, I'm trying to decide what. I think that the easiest solution is just what I said. Like for this, I'm trying to think of like for the future, how do I want to like put this in the instructions?
Just creating a new Ruby object. Save is translating through the ORM into SQL.
Exactly. So why would we want to break it down into 2 steps? Well, maybe we don't necessarily want to save something to the database. Maybe we first want to check something about it before we say, okay, yeah, this looks good. Now let's save it to the database.
So you could create a Ruby object, do some other things with that Ruby object, and then be like, okay, after it hits like this checkpoint, then only do we want to create it actually in our database.
Exactly. And that's mostly what we'll talk about in our SAD path class. I think it's called SAD path and flashes actually. Yeah.
Okay.
Wait, so I have a question. So after we inputted the line with the task.new and then had all the info, if we were to have then done something else, like even added another object there, would we lose the, and okay, sorry, I'm getting all mixed up. So if we did that first line and we didn't do task.save and then we did another thing, would that first thing just like disappear because we didn't save it?
It would disappear eventually. So Ruby objects are garbage collected after certain points, and we haven't quite talked about like MVC and how like the model view controller works. But yeah, if you created that new object, but you never saved it, then eventually it would just like go poof and that data would be gone.
Okay.
Yeah.
How long is that time frame? Is that like pretty quick or pretty long?
It's at the end of the request response cycle.
Okay.
So very quick.
Oh, okay.
It means very quick. Yeah.
I wasn't sure if it was like until like you exited that IRB session or something like that.
Oh, gotcha. So yeah, I'm talking more about in the context of a whole Rails app. In the context of this IRB session, it would be as soon as that IRB session is closed, or if you overwrote the variable that is storing it. So if we say like task equals task.new, and then we say like task equals 4 or whatever,
Sure.
just like another Ruby value, then that task, Ruby says, oh, there's no variable to access this thing anymore. So it just garbage collects it.
But in the context of the IRB session, as long as we didn't reassign it, it would be there throughout the whole IRB session.
Yep. And as soon as you closed it, it's gone.
Right. Like everything else in IRB. But in the real world, the rules are going to be slightly different in like an actual Rails server that's running.
Yeah. In the Rails world, it's the garbage collection will happen sooner than that. So
got it.
Awesome. I think you all are doing great. You're asking all the right questions. So I'm gonna leave you to it. Work through those. If you finish this activity, take a couple minutes and look at the checks for understanding.
Cool.
Would it be single quotes?
Hey, Brian.
Hello.
I'm running into some issues, and so we're just trying to troubleshoot them, but we haven't been able to make a ton of progress.
Take a look.
Essentially, can you see my screen right now?
Mm-hmm.
When I try to run this command, I get a undefined method. And then when I also do task.all, I also get an undefined method.
Mm-hmm.
And we're kind of trying to troubleshoot where that's coming from.
Mm-hmm. So where, in your mind, where do we get the ability? So like from mod 1, we know we can't just call like create and all on these things. Like what gives us the ability to call these new methods?
Application record.
Mm-hmm. Yep. So we need to make sure that our task model is connected to application record. So let's pull up the task model. Do you see the problem there?
This should be application record.
Exactly.
And then the scope base, is that what you need to add as well?
Nope, just like that.
Okay.
So can you also pull up, Kyle, can you pull up application record?
Yeah.
Oh, so something you can do here is this will do fuzzy find. So just type in REC like right now. Nope. Do like go back to where you were before, where you typed in start typing application, and then just type REC. So you don't have to spell it the full word. It'll just find the
okay.
matches.
Cool. Oh, and this is just exactly what you were talking about.
Oh, that's where it is. Active record base. Okay.
Yeah, so that we have like this two-step inheritance chain: active record
Right.
base, application record, then our model.
So there's like, what is it? Ancestors or like a grandparent class or whatever it is?
Yeah, it's the grandparent. So yeah.
Cool. Okay.
So Kyle, you just had application controller instead of application record.
Correct.
That was the issue.
Cool.
And it looks like that is working now.
There you go.
Sweet. Awesome. Thank you so much.
You're welcome.
And I have one question. So like active record is basically a wrapper for SQL. Is that right?
Yeah, it's like a wrapper. I think the way that I'll show you a diagram when we come back. But I think of it more as like sitting in between our Ruby program and our database. So rather than like a wrapper, yeah, it is a wrapper around it. Yeah. But you can also think of it as just like translating what you want to do in Ruby into SQL. So it's like a translator.
Yeah. I have done a little like side project with trying to implement or like trying to create a Discord bot with Ruby. And there's people that have made a library for using like a translation between I assume it's some form of using their Discord API, using it, like making it usable with like Ruby methods and stuff like that. Is it kind of the same premise of like having a library that translates some, for instance, the Discord API into Ruby, stuff like that?
Yeah, I would say it's a similar pattern, and the pattern is an adapter pattern where we have this thing that is just responsible for translating what we want to do in this language into whatever the language is on the other side. In this case, it sounds like it's an API. So what does the API expect to see? That's what this library is doing. I do want to point out that wouldn't necessarily be considered an ORM.
Right.
Yeah.
So Brian, what do you say? So when we do task.all.toSQL, is that basically just giving us the SQL code that task.all is translating for us?
Exactly. Yeah. That's, hey, translator, tell me what your translation was.
Cool. Sweet. Como se dice this SQL stuff?
Yeah, exactly. Cool. All right, everybody, welcome back. I'm going to power through the end here and not do a break. Hopefully we'll end a couple minutes earlier, but I definitely want to talk about some key concepts. I had a lot of good conversations while I was in breakout rooms, and I would like to just kind of like make everyone aware of some key points here. Can you all see my key takeaway slide? Yes, okay. Hopefully I won't have to check that every time. So some key takeaways from this activity: your active record objects are a representation of what is stored in the database. They're not exactly the same thing as what is stored in the database. There are times when like your active record object could actually get out of sync with what the current version of the database is, but mostly these active record objects represent what is in your database at any given point. Active record comes with a lot of built-in methods for querying the database that you experimented with in this last activity. So when I've talked about CRUD a couple times for create, read, update, and destroy. Those methods that you just explored, those are the methods that you're going to use to CRUD records. Create, and they are the exact words. They are create, update, destroy. And then for reading, the one that we showed you is all, which will get all of a certain resource, and then find will find a specific one by an ID. So those are all the methods that you absolutely need to know for CRUDing resources in your database, and that's what you should be doing. We talked about in the project check-in how the first section of user stories for the parent, you should be using all of those are your CRUD resources or your CRUD stories for the parent. You should be using all of those methods in those stories. All of your active record commands are going to end with SQL. All of your active record commands under the hood are going to execute a SQL command. So when you do what in the group I was just talking about with, we talked about how you can think of active record as essentially a translator from Ruby to SQL. So I've got a diagram here. Let me show you what this looks like. So we've got a database over here on the left. This database, as we've talked about earlier, this database speaks SQL. That is its language. That's how it knows to talk. It talks in SQL. Over on the right here, we've got our Ruby program. We don't want to speak SQL over here in the Ruby program. We're speaking Ruby over here in our Ruby program. So we've got one thing that speaks Ruby, one thing that speaks SQL. So what we need is a translator in the middle of them. That's what active record is. Active record translates Ruby into SQL and vice versa. So what this process is going to look like is our Ruby program is going to tell active record through active record methods, hey, this is the thing that I want to happen. So model.create, model.update, .destroy, whatever. We're going to call some active record method. Active record is going to say, okay, this is the thing you want to say. I'm going to translate that into a SQL query. The database will then take that SQL query and it will execute it. And it will have some sort of like return value, some sort of something it needs to give back. And that is going to be the raw data in SQL. So the database is going to give you back your raw data. So if we say task.all, here is the raw task data in the form of a SQL table. Or if we say task.destroy, there might not be any data to come back. It might just destroy it and not do anything. But a lot of the times it's going to send back some of this raw data. And so active record,
the slides are frozen.
Again? What can you all see?
I see the database illustration and the 3 bullet points above, but that's it.
It's just like stopping in the middle.
Yeah.
So it's still frozen?
Yes.
So it seems this is more of a freezing issue. Okay, let's try this. And can you see Ruby program?
I'm seeing the same thing as before, where it just tells me your screen sharing.
Oh man. Let me try. Can you see it now? Same thing.
Yep.
Okay, well, let me try the fix that I did earlier. What about now?
Same thing.
Oh man. Still nothing?
Mm-mm.
Okay, well, let's do this. If everybody could pull up the slides they're linked in the calendar, and it's the very last slide, and there's a diagram for key takeaways. I guess I'll stop sharing. Can I get a hand raise when you've got that when you got that diagram in front of you?
Sorry, where are the slides?
In the calendar event, they should be linked.
There is not a link in the calendar.
I think it's just the lesson plan.
Lesson survey in Zoom.
Dang it, I must have not hit save on that. Sorry, y'all. Sorry for all these technical issues. I'm just gonna drop it into the chat right now. Where is my chat? Okay, so I'm dropping it into our Zoom chat right now. So you should be able to click on that and head to the last slide. And yeah, go ahead and give me that raise hand when you all have got that in front of you. Jeremiah and Joseph, are you all able to get to it? Oh, Joseph, I just saw you just sat down. Go ahead and look in the chat. I linked my slides. I'm having some technical issues, and head to the last slide. And that's what I'll be talking through. Okay, so this slide, and I'm bummed because it had some awesome animations, but that's okay. But this diagram is kind of like our how we view active record as the translator. So starting in the top right of that diagram, we've got our Ruby program. Our Ruby program is first going to call an active record method like create or update or whatever, or destroy. Active record is going to take that active record method, translate it into a SQL query that the database can understand. Database then returns raw data back to the active record. Active record takes that raw data, transforms it into Ruby objects, and that's what we get back from our Ruby program. So this is important to know because under the hood, or sorry, if you don't look under the hood, it just seems like, oh, I execute this method and then I get back a Ruby object. So it kind of seems like everything is in Ruby. And there's actually this rich interaction of active record, the ORM, and the database all working together here. Yeah, so that activity also introduced you to the toSQL method. The toSQL method is essentially saying, hey, translator, hey, active record, how would you translate this? How would you translate .create? And that will print out to you what the SQL looks like. Does anybody have any questions coming up? Karen.
Yeah, sorry. You said that active record acts like a translator between SQL and Ruby. Is that right? Okay.
I would say the database and Ruby.
Okay.
No, I think no. Sorry, that's good. Yeah, it's like the things that it's translating between are the Ruby program and the database, and the languages it's translating between is Ruby and SQL.
Okay, thank you.
You're welcome. Ben.
And so when we're using these active record methods, we have to give like pretty specific syntax for how we use that, or else it'll like not recognize it as a valid SQL query. Is that right?
Yes. These active record methods do have specific syntax that they are expecting. One thing that you might run into is that the active record might not tell you that your syntax is off, you might actually see a database error telling you your syntax is off. So that is, if I'm looking at my diagram again, that's kind of the third leg there, where we call an active record method. Active record tries to translate it to SQL, but then the database comes back and said, hey, I didn't exactly get that translation, or something's off about that. Kyle.
Is active record something that we can only use in like a Rails project, or is that something that can be pulled out and be independently used with Ruby?
No, it's not something you can only use in Rails, and that's a really good point to make. So there are other frameworks that this will play really nicely with. Sinatra is one that you'll get exposed to in Mod 3. But yeah, that is a very important distinction to make, that active record, although it comes by default with Rails, it's not synonymous with Rails. It's not only used in Rails. Great question. Oh, we got one from Jake.
Hold on, so Kyle just blew my mind with that question. So active record is the translator, and you type in the .new.create, I'm sure there's a ton of other methods. Active record is then looking into the database to be like, hey, what kind of a database are you? What kind of a language are you speaking? And then it can translate to like multiple languages to speak to multiple databases.
Yeah, exactly. So if we decide, oh, if I'm looking at that diagram and my database is Postgres, and then I want to go into like MySQL or something like that, active record will take care of any discrepancies between how those two databases talk. And what the advantage is that our Ruby program doesn't need to change. Our translator will do it for us.
So for us then, as long as we have like very, very, very firm grasps on active record, there's not necessarily a dire need to learn all these other like one-off type of SQL languages. It's probably helpful, but like active record can handle that for us.
Yeah, exactly. You've got it. And I will say that most databases, the SQL between most databases doesn't change that much, but there are like small things. There are small differences that if you swapped out databases, you would have to find those small differences. Active record, that's one of the big advantages. That's what I meant when I said it's database agnostic.
Got it. That's really cool.
I'm glad you think so. Tommy.
Yeah, so I'm just trying to like wrap my head around it all based off what Kyle asked as well. So active record, it translates between a database and Ruby or like whatever, and that translation actually occurs within a Rails environment, right? Or is that not
in our case,
completely
yes.
accurate? Okay, cool. Sweet.
Got it. Yeah. So active record is a Ruby library. So you could like dig into the active record code and like see exactly how it does it. But the nice thing is that we don't have to do that. We can just kind of trust that it works. Justin.
Yeah, I'm struggling to kind of grasp what the model is. I guess it's like I was getting caught up like reading definitions about it where it sounds like some of the model can actually be defined by CRUD, but it's the object itself, like the column object. I don't know what it is.
Yeah, that's a good question. Does anybody want to take a stab at this? Like, how would you describe our Rails models? Jordan, I see your hand up. I think you have a separate question, right? Cool. Chris, go for it.
Not totally sure on this one either, but would it be every row that you're creating and turning into an object? And basically everything from active record, when you call like .all, it's like every single row from that table, basically. And like every object is like one row, and that's like what your model is communicating with.
Yes, every object, every row is represented as a single object. So using the same language that same vocabulary that you all learned in Mod 1, an instance of our model class, so in this case, task, an instance of task represents a single task record from our database or a single row.
So the app, like it wouldn't have one model, it's going to be many models for each object. Each object is a model.
Yeah, each instance of our I would say each object is an instance of one model. So we have one model,
Okay.
which is the class. We have one defined class, but we know from Mod 1, when we have a class, we can make many instances we can make as many instances from that class as we want.
Right. Cool. Thank you.
So let me ask you all this. This is kind of like a harder one. If each instance of the class or each instance of the model represents a row from our table, what does the class itself represent? What is the model class itself? What is our task class? Doug?
That would be the table itself, correct?
Yeah, so you can think of the class as that is the table. So when we say task.create, when we call that on the class, we're saying, hey, whole table, make a new one of yourself. Versus if we're trying to destroy a task, we have to say, hey, specific task record in the table, go destroy yourself. Go destroy yourself is my new favorite insult. I'm gonna throw it at people. All right, Jordan, what is, go for it.
Cool. So I guess this may sound a little naive, but like, why learn SQL at all? Or like, better question maybe, when does active record fall short?
That's a great question. So yeah, if active record is so great and it translates for us, like what's the point of understanding SQL? What we will find in some of our more advanced active record classes is we actually have to write SQL fragments, which is just like small little bits of SQL. So in that way, we can't totally get away from writing SQL. It's kind of like we say, hey, active record, we want you to do this thing. And it's like, I don't quite have a translation. Or like, all right, we'll help you out a little bit. We'll give you this small little bit that we really want to do. So that's a big reason why we would, why we need to know SQL. And then the other thing is for debugging. So we might get like some feedback from our database saying like, hey, this SQL query doesn't work. And if we didn't know anything about SQL, we might not be able to use that information at all. So SQL, I would say your understanding needs to be like, you need to like have an idea of what most SQL commands are doing. But as far as like the exact syntax, you don't always need to know that. It's more of like you need to understand, but not master it.
And if I can I kind of add on to that, Brian?
Please do.
One thing that I've noticed that comes really in handy about understanding a little bit of SQL, especially like just my experience working with Rails, sometimes there will be concerns about, oh, I'm not sure if this is going to be an N+1 query. This might not be very performant. And if you're comfortable enough with SQL, you can just go peek in the console and run your active record and then see the output of what SQL is running. So if you're doing the same computation 28 times, then that's probably a query you want to try to refactor. So that's how I've used it, even though I haven't really written much SQL myself.
Cool, thank you. That's great.
Thank you, Jameson. Genevieve.
So I'm curious, like with the methods that we used for destroy, create, new, and then capital T, like task, is our table, right? Or the class that we created, task. So if we did capital task dot destroy, does that work, or does that only work on an object?
I have never tried that. I would say try it and see what happens, but I would imagine that it would probably say like undefined method for our task class. Do you have that open, Genevieve? Could we try that?
Yeah.
Let's do it.
Yeah, I was just wondering if like, does it drop the table if you do it on the class?
If it did anything, that's what I would expect it to do, or maybe not drop the table, but just remove all the records from the table. But yeah, let's try it.
Okay, well, here we go.
Yeah, so it's what it's expecting there. It says wrong number of arguments given 0, expected 1. It's expecting you to pass it an ID of which task you want to destroy.
Got it.
Yeah, so this is a great example. If the capital T task kind of represents our whole table, it doesn't necessarily make sense for us to try to destroy everything. Like there would be very few use cases for like just destroying all of them. Now, if you did want to do that, there is a command called destroy_all that will do that.
Got it. So, but this method, for example, here is really just working with the instances. So are we going to learn later how we create a new table or a new class, I suppose, through Rails? Does that come later?
Yes, and we're not going to do it in code. We're going to do it through migrations, but we'll get there.
Okay, awesome. Thank you.
Let's hear from Trevor.
I was just gonna piggyback off that last thing and share that we were working on that in our group. We did find out that if, at least for capital T task dot update, when we called it on that, we were able to change all of the like values in the table at once, which was a little weird. We didn't expect that to work like that.
Yeah, I wouldn't expect that either.
Yeah, I can actually real quick, like,
yeah, it'd be
awesome. In here we were trying to go back, so if I go up, we ran task update title new, and it updated all of our titles to new.
Yeah, could you scroll back up?
Definitely wasn't something I expected. Yeah.
And I want to point something out here. We can see when we do this, we can see all the SQL queries that it's doing right here, and you can see it does 4 of them sequentially. It does one for the ID of 2, for the ID of 4, for the ID of 5, for the ID of 1. Yeah, so that's something that you would need to be careful of. If you do capital T task versus lowercase t task, if you have a variable called lowercase t task, you could potentially like mess something up. Yeah. Ben.
And I think the reason this is working is because our controllers are inheriting from the, the second level controller, which is in turn inheriting from the active record. So I'm wondering if there's a way, in order to not have that kind of option to, mess with the values of the table all at once, if you could have some way of like restricting the inheritance of some of the methods that come down from the active record or something, because that task class is just effectively inheriting all the methods from the active record.
Yeah, so if I understand your question correctly, is there a way that we could like add in some potential like security to make sure that we didn't accidentally use a method we didn't want to use?
Right, like how you can have that super with the no arguments, and it won't inherit any of those attributes or whatever.
Yeah, I don't want to go too deep into that right now, but the way that I would do it is I would override the method in the model, and I would essentially have it do nothing or throw an error saying you shouldn't call this method. That's how I would do it. Yeah. Kyle, I want to get to your question, but I want to ask one more to the group that I want to make sure we talk about before we break here. If anyone absolutely has to run, that's fine. I am recording this time, so this will be on the recording. What is the difference between new and create? Karen?
I guess I'll try. I think so. New will not like save your object that you create, and create will give it an ID and put it in the table.
Yeah. Yeah. So then a follow-up question, Karen, is like, what does save do?
It looks like save adds it to the table.
Right.
And gives it an
Exactly.
ID. Okay.
Yeah, you got it. Yeah, so create is going to actually add it to the database, and and save is going to actually save it to the database as well. What does new do then? Joseph, do you want to take a stab at that?
Yeah, what I was kind of thinking it was like, doing like task.new was just like creating an instance
Yeah, you can think of create as new plus save. So like you said, new creates the instance, save will save it to the database. And something that's really important to point out here, well, I'll ask this as a question. Where do we get the ability to call .new from? We get like .create from active record. We inherit that from active record. What about new? Katie?
Is that from Rails? Is that something that we get from, from Rails in general, or no?
Not quite, not quite. And the reason why I know that we don't get it from Rails is because we were able to use this method in mod 1. Jake, what do you think?
We're getting it directly from Ruby.
Yeah, exactly. So this is the same new that you're used to in Ruby. When Joseph says this creates a new instance, like you all have been doing this. This is not new. .new is not new. .new is the same .new that you've worked with. .save is the extra thing that we're adding on top that now says, okay, take that object and its data and go save it to the database. So at the end of class here, if there's one like key point that I want you all to take away, it's that these things that we're doing in terms of the database is what you've done in mod 1 plus layering on stuff. We're storing things in files like CSV files, but we're layering on a database on top of it. It's just like a more sophisticated CSV file. We're still creating Ruby objects, but now they inherit from active record, which makes them models and gives us access to active record things and connects them to the database. So I don't want you all to lose those core concepts from mod 1. They're still like directly relevant. With that said, I've got a couple hands up here. Let's hear from Doug.
So I had a question about the create, because in our task manager, we had to create a method called create. Then we did task is equal to task.new, task.save, redirect to tasks. Is there a existing create that we overwrote? That way we could also include that redirect? Or do you always have to create that create method?
So that create method, this is a little confusing because that create method that you made is in the controller, not the model. So you're not overriding your active record method that you get. You are creating a separate method in a controller. And that that can be confusing because a lot of times the controller action name and the method that we're calling are the same thing. So we could have a create action in our controller and inside that call the active record create method, but they are two separate things. Does that answer your question, Doug?
It answers my question, but creates a lot more questions, but I think I'll have to do some research on that.
Perfect. Andrew.
So when you do like task.new, it stores that until you save it, it stores that instance. So would you be able, and I tried doing this and it doesn't seem like it's working and it's being all weird now, but if you were to create a new task and then another new task, would it store both of them? And a task.save would then create both? Or can it only store like one at a time, one instance?
So in Ruby, one variable can only store one object at a time. So if you name it if you name the variable the same, then that will override what you previously did. So if I say task equals task.create and do one, and then say task equals task.create again, that first task is now gone. It's that I don't have a variable to access it. I've overrode what that variable is holding on to.
Okay, cool. That's what I forgot to save it as a variable. That's why. Cool. Thank you.
You're welcome. Kyle.
I think my question from before was just that, are there ever moments when we find ourselves understanding the SQL and we have to like dig into active record to see what that Ruby language is or what that active record language is?
If you're doing that, then you are in a good spot. it is a lot easier if you know the SQL. If you really know how to write the SQL, translating it to active record is pretty easy. Is almost trivial because the SQL is the hard part. And that will come up later in some of our more advanced active record classes. All right, y'all, I think this is a good place to wrap up. I'm sorry for going a little over, but we did run into those technical issues and I didn't quite get as many palms in as I wanted to. So I do apologize for that. I'm gonna post this recording in case like your attention, maybe like, I understand if it was a little hard to pay attention all the way through this 3-hour block. The one thing I wanna leave you with in terms of like, what you can be working on, if you're feeling like you're kind of like at a place in the project where you're not ready to like work on it, or maybe you've done what you can and you're kind of waiting for lessons, I would highly recommend working through those checks for understanding. And if there's anything there that you aren't 100% clear on, throw it in the code help channel and we'll talk about it there. So cool. And then I'm going to close this meeting. Please open up that survey. That one is linked in the calendar, and give me a quick, like, 30 seconds of boom, boom, boom. This is what I think of this class. And after that, go to lunch and be on the lookout for our attendance thread for the work time in the afternoon.
Thank you, Brian.
You're very welcome. And for this afternoon, Jameson and I are going to be meeting for about an hour from 1 to 2. But if you have any questions and want to talk about anything, feel free to shoot us a DM and we'll get back to you.
Thanks, Brian.
Thank you so much.
Thanks, Brian.
Thank you.
Brian.
Thanks, Brian.
Thank you.
Yeah, thank you all.